Today we're going to talk about systems of linear inequalities. Before you tackle this topic, you need to know how to graph a single linear inequality in two variables. A system of linear inequalities consists of two or more two-variable inequalities and their graphs. Today we're tackling systems with only two inequalities. And just like in a system of equations, we're looking for a set of points that make both inequalities true. So let's take a look at our first system. We have two very distinct and separate inequalities. Y is greater than or equal to 2x minus 3, and y is less than or equal to negative x plus 1. We're going to take these one inequality at a time and graph. So let's take a look at that first inequality. Y is greater than or equal to 2x minus 3. Because of the greater than or equal to, we're going to graph a solid line with a y-intercept at negative 3 and a slope of 2. Then of course we're going to pick a test point. And I found, thanks to my test point, that I shade to the left, or I could say above, my red line. Then I'm going to graph the second inequality. Same procedure. Less than or equal to means that I graph a solid line, this time with a y-intercept of 1 and a slope of negative 1. And picking a test point, I find which side of the graph I'm supposed to shade on. Now, in a system, we need to find, again, the points that make both inequalities true. In a system of inequalities, that means this area where the two shadings intersect. The red area indicates all the points that satisfy the first inequality, and the blue area indicates all the points that satisfy the second inequality. So the part that's both shaded in blue and red, or the part where they intersect, is the area that contains all of the points that make both inequalities true at the same time. So if I just shade that intersecting area, that contains all of the points in my solution. And just to kind of check to make sure that that's true, I'm going to pick a random point in that shaded area. I'm going to plug it into my first inequality, negative 4 for x and 2 for y. When I multiply and simplify, I get 2 is greater than or equal to negative 11, and that's definitely a true inequality. Then I'm going to do the same thing to the second inequality, again substituting negative 4 in for x and 2 in for y. Be careful with the negative x. This is an area where lots of students make mistakes. It's saying the opposite of the x value. So I want the opposite of negative 4. When I simplify that, the opposite of negative 4 is a positive 4. And 4 plus 1 is 5, so 2 is less than or equal to 5. Again, a true statement. And since both inequalities are true, I know that I have the correct shaded area. Just as a quick side note, notice that those two lines actually divide my graph into 4 very distinct areas. The section that I have shaded now satisfies both inequalities, but I do have a section up here that's going to satisfy the first inequality and not the second. I have an area down here that's not shaded anymore that would satisfy the blue inequality but not the first, and an area off to the right that wouldn't satisfy either inequality. So one option, if you don't want to take the time to shade everything, is to pick a test point from all 4 areas and see which area satisfies both inequalities. Alright, let's take a look at one more. We're first graphing the first inequality, y is less than 4x minus 5. Because this is only less than or solely less than without the equal to portion, that means that we're going to graph a dashed line with a y-intercept at -5 and a slope of 4. Then I'm going to pick a test point and shade the appropriate side. Then I'm going to graph the second inequality. Less than or equal to indicates a solid line. And this one, instead of just writing x, I could change that into 1x plus 0 so that I can see that I have a y-intercept at 0 and a slope of 1. And picking a test point, I can find the area that needs to be shaded. Then, of course, since I'm finding the system of inequalities, I need to find the area where the two shadings overlap. Since you probably don't want to erase all of the shading that you've done before, you could simply fill in this area where they overlap with a third very distinct color so that people can tell where your answer is supposed to be. One option is to shade very lightly, maybe with pencil in the other two areas, and then maybe take a colored pencil or something equivalent and shade the area that you want to be your final answer. Anyway, the two areas where they overlap is our final answer. This area holds all of the points on and on forever that satisfy both inequalities or make both inequalities true. Again, in our four distinct areas, there's going to be one area that doesn't satisfy either inequality, one area that only satisfies the first inequality, and one area that satisfies only the second. And then, of course, the area that we shaded that satisfies both inequalities at the same time. So if you don't want to take the time to shade, pick a test point from all four sections and see which section satisfies or makes both inequalities true at the same time. Just to wrap this up, we graph the first inequality and shade the first inequality. Graph the second inequality, then shade the second inequality. See where the two shadings meet and color the intersection. And that intersection is your solution. That section contains all points that make both inequalities true. Okay, I think that's enough for today. I hope the rest of your day is grand, and I'll see you next time.